Alright, so welcome back to Intro to Artificial Intelligence. In this video, we are going to take a look at structure of agents and types of agent programs. So in other words, to say structure of AI itself. So remember, an agent is a core of AI, but not the complete AI itself. But explaining and studying more about the concept of AI as agents is easier and gives us more in-depth understanding of what we are trying to make. So there are two main aspects of an agent structure. The first one is agent program, and the second one is the agent architecture. First, we take a look at our agent architecture though, because it's super simple. Agent architecture is basically the way an agent's sensors and actuators are designed. As an example, the steering wheel of an autonomous vehicle controls would be the actuators that the agent programs can use to turn the vehicle. And the sensors on the vacuum in that example allows it to sense the clean and unclean areas. And so let's take a look at agent programs, and there are many types of agent programs. First of all, what is an agent program? To understand that, we have to take a look at how we usually construct a working plan for an agent. We make a table where there are all the possible percepts from an environment, and then write down an action against that percept against that entry. So every time an agent encounters a percept, it looks at the corresponding action to perform against that percept, and then it does that. But the problem with such sort of structure is that there can be trillions of possible percepts for each single environment for an agent. And for example, a game like chess would take 10 raised to the power 150 entries of the table. This is extremely large amount of entries, and no hard drive can have that much amount of space if we are thinking realistically. And so we want to write a program that produces rational behavior with small amount of code rather than large lookup tables. And so that's why instead of using lookup tables, we use agent programs, as you will see in the future videos, to make rational behaviors artificially. And there are many methods of doing this. In other words, there are many different types of agent programs. We have simple reflex agents, model-based reflex agents, goal-based agents, and utility-based agents, and learning agents. Let's study them one by one, starting off with number 1, reflex agents. The simplest kind of agent is the simple reflex agent. These agents select actions on the basis of the current percept, ignoring the rest of the percept history. They are suited for observable environments only. Even a little bit of unobservability can cause serious trouble. But first, what exactly happens is that the simple reflex of agents are based on a condition action rule. An action is initiated as soon as the condition is established. Like for example, in case of vacuum cleaner, if the condition is being met that there is dirt present, perform the action of cleaning. Or in case of self-driving cars, if the condition is met that the car is sensed in front, perform the action of brake on the car. Because reflex agents are quite simple, the intelligence is also limited. For example, the car will use the percept of a car in front being stopped to press the brake, but it has no idea that the car in front of it might be broken down or it cannot move. In such a case, the agent will permanently keep in the state of brake behind the stopped car. Infinite loops are often unavoidable for simple reflex agents operating in partially unobservable environments. Next up, we have model-based reflex agents. In simple words, they are literally what they sound like. Reflex agents with model of the world. Recall that simple reflex agents cannot handle partial observability. And the most effective way to handle partial observability is for the agent to keep track of the part of the world it can't see. That is, the agent should maintain some sort of internal state that depends on the percept history and thereby reflects at least some of the unobserved aspects of the current state. And that deals with the partial observability of the environment. The actions of models-based reflex agents are based on current percept and old internal state of agent. An internal state is updated after each step. A model-based reflex agent takes percept from the environment and then updates its internal state by using that percept. It then looks up the rule against that state and gets the action from that rule and performs it using the actuators. After each iteration, the internal state is changed and stored. Such is the working of model-based reflex agents. Then we have goal-based agents, where the actions of an agent are dependent on only the current state of environment and the goal, where a goal can be anything. Like in case of vacuum cleaner, the goal is a clean floor, and in the example of self-driving car, the goal state is like the car being at destination. And to achieve that goal, the agent has to plan and search. A goal-based agent takes percept from the environment and stores the current state of the environment, then checks in with the internal goal of what it is trying to do, and checks what action should it perform that helps it achieve its goal, and then performs that action. And then comes the utility-based agent program, because goals alone are not enough to generate high-quality behavior in most environments. Utility is basically the performance measure that allows it to have a binary evaluation of the environment in the form of good or bad, or happy or unhappy. The utility function maps the current state to a real number describing degree of good or bad. It is essentially an internalization of performance measure. If the internal utility function and external performance measure are in agreement, then an agent that chooses actions to maximize its utility will be rational. And like mentioned before, goals aren't enough to generate high quality behavior, and so utility functions are actually better than goals because there can be more than multiple goals and they can be conflicting. For example, there can be a goal of getting to destination in the fast speed, but that contradicts the other goal of agent that could be the safety of the passengers. So utility-based agent uses a model of the world along with the utility function that measures its preference among the states of the world. Then it chooses the action that leads to the best expected utility, where expected utility is computed by the averaging over all the possible outcome of states. And last but not least, we have the learning agents. You see, to design all the other sort of agents by hand, it takes too much effort and time. And so we wonder, what if we could make an agent that learns automatically? This could be super useful in dealing with environments that are actually unknown even to us. And by learning automatically, as the time passes, an agent can become more and more intelligent. So learning agent consists of a learning element, which is responsible for making improvements, and a performance element, which is responsible for selecting the action of the agent and gives feedback to the learning element. Then the problem generator, which suggests new actions and will keep repeating the same actions if not for the problem generator. The learning agents are the fundamental of machine learning, as we will take a look at the differences in the terms like deep learning, machine learning, and AI later on. So you can read more about these agents types on the internet, and I will make sure to put some reading material under the section of this video. In the next video, we will take a look at the goals of an agent and start breaking down on how computer or an agent can solve problems intelligently by breaking them down into subtasks. And so with that being said, see you in the next video.